Cool. 956, tallest billboard. You are installing a billboard and wanted to have the largest height. The billboard will have two steel supports, one on each side. Each steel support must be an equal height. You have a collection of watts which can be rolled together. For example, you have watts of 1, 2, and 6. You roll them together to fit a support of 6. Return the largest possible height of your billboard installation. You cannot support the billboard. If you cannot support the billboard, return 0. Okay. So this is just subset sum, right? Largest subset sum. So then, oh, actually, n is equal to less than 20. So, I mean, subsets, you could solve this in a number of ways. But because they tell you that the sum of each or the watts is at most 5,000, probably going to be subset sum. You can actually, technically, if you, like 2 to the 20 is like a million, which is maybe barely too slow, at least on Leetcode, at least on Python on Leetcode, because I think a million is way fast, but on Python it's just a little slower for whatever it is. But given that the sum of the watts is 5,000, that means that this is actually going to be a subset sum, which, you got your code, which is dynamic programming. So yeah, the sum of the watts is almost 5,000. Okay. And in this case, you want to use each watt at most once. So let's get at it. Python 3. Oh, I would do it in C++ because that's what you request. I don't know, maybe it's a little better. And also, I do need more practice of Python with dynamic programming, but it's fine. It doesn't really matter. But yeah, so now, so subset sum is a specific type of dynamic programming, in that it is pseudo polynomial, not necessarily polynomial. So we'll just do let's just do a can array. Is that a good name? Naming is hard, right? Also typing is hard too. Do Python? Are you kidding me? Okay, it's too late. Maybe next time. Troll. Yeah. So yeah, I'm using C. Then I think people use Vec. Maybe I should be better about C++ and like do C++ things. But yeah. So, and this is technically Boolean, which I'm still bad at doing sometimes. Because you could actually do it in boot vector and okay. Anyway, so yeah. So now you can always get to 0. And then now for each watt, yeah. Actually, I guess the cool kids use auto. Kind of, except for it's a replacement in the pre-processing stage, versus and there's some nuances there, but that's kind of the short. But essentially, you can think of it that way, until you can't when it breaks because of certain situations. But not for hours. Oh yeah, and then now let's just do. And then now we just want. Oh wait, they have to be the same sum, right? It's not just. Because I was thinking of a version where you could cut one off, so that in some cases, okay. So whoops, maybe this is a little off then. But let me think about it for a second. Huh. Do I need to take advantage of n is less than 20? Maybe I do. Maybe I don't need dynamic programming in that case. So I do. Well, then that'll be 3 to the n, maybe. Okay. Well, it's still dynamic programming. But I have to structure this a little bit differently. Because I thought for someone like this case, you could just do 1. But because in this case, that's not true. Because you have 1 and 2, and then 3. But maybe I just need to count the number of ways. No, because you need exclusive sets. So another thing that you can do is something called meet in the middle. Do I want to do meet in the middle? No, it's probably not that intense. Do I have to use all the watts? Oh no, because I should read this form carefully before I start typing. But I thought it was something that I've seen before. But yeah, okay. So basically, you gotta add So each of these numbers have 3 states. Maybe I have to do tops down. Tops down. 1,000,000 times 1,000,000. Maybe that's 5,000. 5,000. So okay, that's not so bad. Sorry, give me a second. Yeah, maybe I don't know how to do it bottoms up, but there's yeah. So the recurrence, there's a different one. So the recurrence is just here's the recurrence. The dimensions are the index, and then yeah. There's left sum and the right sum, right? And then we could cache based on whether that's possible. Yeah, okay. Guess that's legitimate. Okay. So yeah, let's just do left sum and then right sum, which is what it sounds like. And then now, okay, that's not so bad. That means, and in theory, if you look at this, if you do a dimensional analysis, this means that it's 20 times 5,000 times 5,000, but actually, these two numbers can be represented by one number because you sum them at the end, so that should be okay. But we keep the number so that we could use it to return the max. Okay, cool. Let's do that. Okay. Yeah. And just return go of. Well, I guess we had to. Audio watts. 0, 0, 0. Okay. And then now I had to create the dynamic programming thing. Period of does that give me the best sum? Huh. 20, 21. Trying to think a little bit. If what does that mean if this is cached? That means the best answer is the current best answer. But can you? I think the thing that I worry about is just thinking about the whether this is a correct state in terms of subproblem optimal whether the subproblem is optimal. But yeah, yeah, maybe it is. I think that's how I would structure it. Though maybe the ordering I'm doing it is a little weird. Let me think about this for a second. Outdoors of okay, let's just initialize the array. Okay. Yeah, if this is used, then just return it. Otherwise, I'll typo aside. Okay, and I think I'll take out this. Otherwise, okay. If index is equal to, do I have to wait to the end? That's the base case. Yeah, I guess it doesn't really matter either way. Close some windows because stuff keeps popping up. If otherwise return, do we want the max or the min? Oh, the max, so we just return something ridiculously. Cool. We also have to set this to the best thing. So let's say we only keep track of the left sum. Well, we could just keep track of both and then divide it by 2. I guess it doesn't really matter. But so the best for now is you go to, I guess, negative infinity. And best is equal to max of. Okay, so this is when you don't use the current one. So index plus 1, left sum, right sum. And then also yeah, okay. And then just also go index plus 1, left sum plus or sub index. And that's just, yeah, that's just oops, right sum, and then also add or sub index. I guess this should be symmetric if this is correct. So but I think I'm off by something here. Because you have to confirm that these are reachable first. I guess these are reachable, then otherwise they get negative infinity. Also, maybe my negative infinity is too high. I just won't want to get underflow or whatever. I guess you only need to consider one of these cases. So otherwise you're going to double count both sides. So I guess we can always divide 2. Maybe that's good enough. Why not initialize it? Also, I need to wait, what? Let's put in more cases. That's unfortunate, but 0 is still better than nothing, I guess. Do I add correctly? Do I always get 0? Am I missing some? Yeah, it looks okay. Maybe I have some weirdness. No, it's just getting all zeros. Which means it's possible, but let's do something more basic and then see what happens. Probably have a base case issue, which is Yeah, okay. This will always return 0, which is a good base case. But why is these not returning correctly? Very interesting. Okay, let's see where my prices go. Okay, so it doesn't do any recursion. Oh, I'm just being silly. This should not be. No, I had the base case. I don't need to set it. Okay. I think I was still on the mindset of doing it bottoms up, which is what that's what I've done. Okay. That is just silly. Alright, well, let's just put out the other ones. Put out the other ones. Cool. Then now we can submit. The running time seems fast, but I'm also not doing any big numbers. Time limit exceeded, huh? Must have been. I mean, these are just like powers of 2, so I must have done something weird in terms of the recursion step. Because that is odd. Because the only whatchamacallit, the only 10,000 times 22 is 200,000 cells. So am I not caching correctly somewhere? That's my only guess. Because each of them obviously do a constant amount of work, so oh, why did I forgot to print out the thing that was in my mind? Been traveling on my mind. No, it'll probably print too much, but that's fine. I just want to see whether certain situations are being doubled. I guess I need to put this here actually, otherwise it might. Oops. Well, okay, but that shouldn't be the case because we only have, unless I'm like running into some memory access type things, and because I'm bad at math. But they said the sum is less than 5,000, which this appears to be less than. Output limit exceeded. But yeah, this should not be 500,000 print. So that means something is going on to caching. Oh, I see what it is. I'm just being silly again because I use -1 to denote that I'm not visited, but my best sometimes is a negative number, so then it just recalculates. Okay, that's just me being silly. So at least there's nothing wrong with the algorithm, which just happens from time to time. How do I want to think about this? Yeah. I guess it doesn't have to be a negative infinity, right? No, it has to be because otherwise sometimes you can build on top. That's is it okay for it? No, because yeah, you're gonna get into weird states. I think just well, I was gonna say this only happens when it's -1, which I don't know. We can't really test that. All right, whatever. I think I was just being lazy and trying to save a Boolean value, so we could just add that. Um, learn this lesson hardish way, but not too bad. Um, and now let's say if this is seen, we don't do it, and then we say scene. Cool. Yeah, just silly mistake on the impossible cases. Um, cool. Yeah. I mean, this relatively straightforward dynamic programming pseudocode. I think I just had some. Wasn't sure that the subprime optimality is a thing. Maybe I could prove it later. And I maybe also as practice, I'll have to do bottoms up on this one to save memory, but not bad of a deal. And again, going through this problem, this is what is generally known as a pseudo polynomial dynamic programming problem. So you get your wish for dynamic programming, Qual. But yeah, and yeah, and the complexity is n times the max sum of UO times 2, which is obviously all of n times the max sum for k, some k is equal to max sum. Yeah, and that's mostly it. Space is also the same, though you could probably cut a layer of. I think now I know I could do it with for loop. I take that back. I've done this before. It's similar to what I had already. It's just that I have to keep track of another level. I just wasn't sure that this was right to begin with. That's probably why. But yeah, but if you rewrite it using bottoms up, then you could maybe, and then you could save, 20 times the memory ish, or n layer of memory. Um, but but yeah, I would say subset sum or a zero sum or whatever. Or yeah, it's generally something that I have seen on interviews. So definitely practice this. But I mean, this one's a little bit of a harder variation. But I feel like I've seen variations of this before, and I end up taking half an hour. It could have been faster, but about par. I would say definitely people would be good and be faster. But yeah, I don't know if I do any tricks, but as usual, the dynamic programming, the hardest part is the transition, uh, and yeah, and I think just the way I lay it out is actually pretty straightforward. I think the key point is noticing that left sum and the right sum are not two separate states. You could actually just cache the delta of them, and everything here is just kind of making sure that it is within the array and so forth. Cool. And then I have a silly mistake because uh, of the way I did to check whether something was cached, which is usually works, but in this case, because of the negative sums that happen, that didn't work and cost me a submission. But yeah,